to go to mainland China for the Chinese New Year. Please take good care of the business.
Okay.
The packs of tea must be put in their proper order. Don't forget that, okay?
Yes, Dad.
And keep the jars of black tea filled, too. Right. See you. Ah, yes. There's a delivery of beau lait next week. Add it to the stock. Can you do that?
Yes.
Good. And order more gift boxes, okay? There's going to be a rush for presents over the New Year. Huh?
Okay.
Bye-bye.
Bye-bye. Huh? How many boxes? I guess I'll have to work it out myself. Hey, Uncle, how much beau lait was ordered?
Oh, 24 kilos.
There are 2 box sizes, 200 grams and 400 grams each. So then how many of each am I going to need? Let X be the number of 200-gram boxes. And let Y be the number of 400-gram boxes. X times 200-gram boxes will contain 200 times X grams of tea. Y times 400-gram boxes will contain 400 times Y grams of tea. The gift boxes as a whole must contain 24 kilos. In other words, 24,000 grams. Therefore, 200 times X plus 400 times Y equals 24,000. Or more simply, X plus 2Y equals 120. Then we solve the equation by moving the terms. Plus becomes minus on the other side, then X equals... How can I find the unknown value?
Having trouble with your calculation? Why not ask Mr. Wong for help? He's always in here.
Oh yes, the maths teacher. He'd be the best person to ask. But I don't know when he'll be coming in next.
There you go, sir.
All right, that's wonderful. Thank you.
Bye.
I'll just ask Sam, right? Sam, how are you doing? I need to order some gift boxes.
How many do you need?
I haven't worked it out yet. I hope you'd help.
Look, I have to go to Kowloon. Maybe we can meet and go over it, okay?
All right. Where shall we meet?
Maybe we can meet somewhere that's convenient for both of us. Right now I'm here in Fo-Tan. And your shop is in Wong Tai Sin? My KCR train goes via Kowloon Tong. And the MTR from Wong Tai Sin also goes through Kowloon Tong. That means Kowloon Tong is at the intersection of your MTR route and my KCR route. I suggest we meet there. So this is the problem? Your equation is correct. However, as there are 2 unknowns, X and Y, we can only express one unknown in terms of the other by moving terms, like this one right here. We cannot obtain the values for both of the unknowns here. This type of equation, which has 2 unknowns, and the degree of each unknown is 1, is called a linear equation in 2 unknowns.
If the unknown values can't be determined, the equation has no solution, right?
No, quite the opposite. It has many solutions. Take this equation as an example. If x equals 1, what should the value of y be?
8.
So x equals 1 and y equals 8, represented by the ordered pair 1, 8. Satisfies the equation. This pair is a solution of the equation.
Oh, I get it. If x equals 2, y equals 6. X equals 3, y equals 4. X equals 4, y equals 2. X equals 5, y equals 0. Therefore, 2, 6, 3, 4, 4, 2, and 5, 0 are all solutions of the equation. So there are many solutions for my equation.
Yeah, but that's not everything. Let me show you something else. When these solutions are represented by dots on a coordinate plane, all the dots will lie in a straight line. If we select any point on the line, say for instance 3.5 and 3, its pair of numbers will also satisfy the equation, and thus form a solution of the equation. In other words, every dot on the straight line is a solution to the equation. We call this straight line the graphical solution of the equation.
So every point on the straight line is a solution of the linear equation in two unknowns. I'll never know how many boxes to order.
You will. You just need another linear equation in two unknowns. Different equations form different straight lines. In general, two straight lines intersect at one point. The point of intersection gives the unique solution which satisfies both equations. It's similar to the interchange of the KCR and the MTR routes. It suits your route and at the same time suits mine. It was the most appropriate point for us to meet at.
How can I get the other equation?
Well, the conditions for x and y have to be determined by you.
All right, I'll take 200 grams, thank you.
Okay.
No, I'll take the bigger one.
Right.
Yes, it's perfect.
All right.
300 grams.
How much?
$150. Thank you.
There were 120 customers today. 42 of them bought tea in amounts of around 200 grams. And 78 bought tea in amounts of 400 grams or more. That's roughly twice the number. Interesting. According to this data, I assume that the number of 400-gram boxes should be twice the number of 200-gram boxes. Therefore, the second equation is y equals 2 times x. By drawing the graphs of the equations, I'll determine the number of each type of boxes. The first equation is x plus 2y equals 120. The second equation is y equals 2x. The two straight lines are drawn, and their point of intersection is 24, 48. That is, x equals 24 and y equals 48. So I need 24 small boxes and 48 big boxes.
You're
Back at last.
Good.
Hi, Dad.
Thank you.
Did you enjoy your holiday?
Oh, I had a great time. And I brought you some top-quality green tea back. Here.
Wow.
You calculated everything just fine. There's hardly a box left over, huh?
Oh, I came up with some equations to calculate the number needed.
Well done, my boy. I've got another problem here. This high-grade tea can be sold at $1,200 a kilo.
What? But that's way too expensive.
I realize that. That's why I want to blend it with the $400 tea to make it less expensive for the customers. The blended tea will sell at $600 a kilo. To start with, I want to blend 5 kilos to test the response. I want to see if it sells well. I need you to work out how much of each kind of tea is required.
There are two kinds of tea, and we have to find out how much of each to use. So let x kilos be the amount of high-grade tea and y kilos be the amount of ordinary tea. The two teas combined must weigh 5 kilos. Therefore, x plus y equals 5. The high-grade tea cost $1,200 a kilo. Therefore, x kilos costs 1,200 times x dollars. Ordinary tea costs $400 a kilo. Therefore, y kilos costs 400 times y dollars. The blended tea must weigh 5 kilos and costs $600 a kilo. Therefore, the total cost of the blended tea will be $3,000. On simplifying the equation, we obtain 6x plus 2y equals 15. We then solve the simultaneous linear equations in two unknowns. The solution of the simultaneous equations is 1.3, 3.8. So we need 1.3 kilograms of high-grade tea and 3.8 kilograms of ordinary tea. But their sum isn't 5 kilos. What went wrong? Is there a mistake? Hello?
Hi, Raymond. I checked your solution. No, you weren't wrong, but a graphical method only gives an approximate solution. That's why you thought there was a mistake.
So the weakness in the graphical method of solving equations is that we have to use graph paper. Tell me, Sam, are there other ways to solve simultaneous equations without drawing?
Yes, we can use the algebraic method. Let us take our example. If we look at the simultaneous equations, we can see that each one contains two unknowns. If we can combine the two equations to form a linear equation in one unknown, we can find the solution.
Combine the equations to form a linear equation in one unknown. The first equation is x plus y equals 5. That is, x equals 5 minus y, or y equals 5 minus x. If in the second equation we change y into 5 minus x, then the equation has only one unknown, x. That's a linear equation in one unknown. I get it. Since y equals 5 minus x, we substitute x with 1.25 and we get the value of y. The exact solution becomes 1.25 kilos of high-grade tea and 3.75 kilos of ordinary tea.
Hey there!
Oh, Mr. Wong.
I need a packet of Bolay, and you'd better give me a packet of green tea, too.
Of course. That's $400.
Right. Hey, look, I don't seem to have enough cash on me. How silly of me. In that case, I'll take the Bolay for now and come back for the green tea later.
That's all right. I'll just deduct it on the register.
Thanks a lot.
That's it. I've canceled it. $150, please.
Okay.
Here. Thank you.
I noticed you were looking pretty busy. You were working on something, huh? What's the problem?
I was calculating proportions for a new blend of tea.
Let me see.
Oh, maybe you'd check it for me.
Yeah, sure. This looks pretty good, but there's another algebraic method for solving simultaneous equations.
Is that right?
Yeah.
Can you show me?
You've used the substitution method to form your linear equation. You can also add the two equations together to eliminate one unknown and to achieve the same result. It's called the method of elimination. The principle is similar to what you did to cancel the cost of the green tea by inserting a negative value.
Oh, that's interesting. Let me see if I can do it.
All right.
We could cancel the unknown y in the first equation by adding it to negative 2y. If we multiply the second equation by negative 2, we obtain the negative 2y. When we then add the two equations together, the 2y and the negative 2y cancel each other out, eliminating the unknown y. We're left with 4x on the left and 5 on the right. Therefore, x equals 5 over 4. That is 1.25. By the method of substitution again, 1.25 is substituted for the unknown x. This forms an equation in one unknown. This time, the unknown is y. Thus, the value of y is found to be 3.75.